Alright, I recorded this part already, but my camera froze as usual. We are doing simplifying radicals today, and you've done radicals before. You've done square roots, that's all they are. You did it in 8th grade, and you would get a decimal answer. I have it already in here from the previous video that froze, so you notice 48, and it gives you an answer there. We are no longer using decimal answers, as decimal answers are not necessarily the most simplified form of a radical. We are actually going to be leaving the sign, if needed, in here to get the more simplified form. It says the nth root of a number a can be written as a radical expression, n root a, where this little number right here, it's not going to appear big, but it's going to appear really tiny, is known as your index. This sign is actually your radical. You may know it as the square root, and the reason for that I'll go over here in a little bit. Whereas the number underneath the radical is your radicand. If there is no index, so no number is shown here, we assume that number is n equals 2, meaning something like this you know as your square root, because it's the same as that, and this is squared, so square root, which is why you may refer to this as a square root rather than a radical. And for Algebra 1, that's all we're going to be looking at, just the square roots. The second portion of this is prime numbers, being able to highlight and recognize your prime numbers. I think it's important that you recognize your prime numbers at least up to 20. If you have those down, I think you're set. Now, if you wanted to go even further, which we did in class, your other set of prime numbers would be 23, 29, 31, 41, 43, 53, 37, 47, 59, 61, 67, 71, 73, 83, 79, 89, 97. And there's your list of prime numbers all the way to 100. Okay. And then the rest of this video did get recorded, so. Just kidding, no, the rest of this video did not get recorded, so I'm going to need to do these two. So if we want to write the square root of 48 in simplest radical form, we do either the birthday cake method or the factor tree method. And that square root of 48 is what I showed you on here earlier, which in 8th grade you would just done the square root on the calculator, got in the decimal and called it a day. And today we're actually going even further to get it in the prettiest form possible. So birthday cake method. I'm going to start off with 48 at the bottom, and I'm going to divide by a prime number that goes into 48 evenly. So a prime number I know goes into 48 evenly would be 3. 2 does as well, so you can start off with 2, but I know 3 goes into 48 evenly because 4 plus 8 is 12, and 12 is divisible by 3. So 3 into 48 is 16. And then into that one, we know 2 goes into 16, 8 times. And then we know 2 goes into 8, 4 times. And we know 2 goes into 4, 2 times. And 2 goes into 2 1 time, which gives you a little candle at the top of your birthday cake. So happy birthday to you. All right, as soon as you have your cake drawn out, and it's a leaning cake, you're going to look for buddies. A buddy is a match, a pair. So there's a buddy. There's a buddy. Notice 3 has no buddy. Neither does 1. So my buddies, we put outside the radical. So there's a pair of 2's, I only write it once, and another pair of 2's, only write it once. So 2 times 2 on the outside of the radical, whereas on the inside is everything that's left over, 3. And in this case, I'm going to go ahead and put 1 just to show you that you also multiply with everything left over on the inside. So 2 times 2 is 4, 3 times 1 is 3. However, that 1 wasn't necessary since 1 times anything is just itself. That's the birthday cake method. The other method is factor tree method. You still need to know your primes for this, but you can start by dividing by whatever. Over here, I kind of start dividing by 12 because 12 is not a prime number. You can start dividing by 4 because 4 is not a prime number. You can start by dividing by 6, by 8, any of that because those aren't prime numbers. So I started with 3, which is on my prime number list. Factor tree does not require that. Factor tree, you can start wherever. So if I wanted to do 12 and 4. But then you'll know that you need to continue because these are not prime numbers. So you continue to break it down until you get to primes. 3 is a prime number, so we stop there. But 4 can be broken down further. And now we're in primes. And this 4 can be broken down further. Now we're in primes. Same as before, buddy system. Buddies, buddies. A set of 2's, another set of 2's. Inside the house is a 3, so 4 square roots of 3. All right. I'm going to do birthday cake, factor, birthday cake. Birthday cake, 8. I know 2 goes into 8 4 times. I know 2 goes into 4 2 times. And I know 2 goes into 2 1 time. There's my candle. Happy birthday. Buddies. Buddy comes out. There's no other buddies. Other ones stay in. 2 times 1, which is 2 square roots of 2. All right, 99, factor tree method. The right-hand side was left to do on your own, so. I know 9 and 11. 11 is prime. We're done there. 9 can be broken down into 3 and 3, both of which are prime. Buddy system. 3 comes out and stays 11. All right, square root of 36 is special because if we do birthday cake method, 2, is that 18? 2, 9, 2 can't go in that, 3 can, 3, 3, 1. Buddies, buddies, a buddy of 2's, a buddy of 3's, and then all that's left on the inside is 1. Well, this is kind of insignificant. Square root of 1 is 1, so 2 times 3 is 6. Meaning, doing this was unnecessary because you should know what the square root of 36 is, and you should know it is 6. All right. Level 2. Only difference here is that there's a number on the outside of the radical. Meaning, once you get to this step, you got to make sure to multiply everything on the outside together. Here's a negative 1. All right, so we have 128. I'm going to show you a quick way to get stopped, hopefully. So 128 we know is divisible by 2 because it's an even number, which gives us 64. 64 is a special number. 64 is a perfect square. Since 64 is a perfect square, we can stop right here. 8 times 8 gives you 64, meaning 8 goes on the outside of the radical, and this lonely guy goes on the inside. Don't forget you have the negative 1, so negative 1 times 8 is negative 8 square roots of 2. As soon as you find a perfect square, know what the square root of 64 is, pull it out, and do your radical. So let's try the next one. Same thing. 98. 2 goes into that, giving us 49. 49 is special. 49 is a perfect square. Because 7 times 7 is 49. So 7 comes out. 2 stays in. And we had an extra negative 6 over here to worry about. So negative 6 times 7 is negative 42 square root of 2. Again, the right was left to do independently. On to level 3. Now we have variables involved. X squared. X squared is x times x. Notice there's a buddy. Buddy comes out. Nothing left over. Square root of x squared is x. Same idea here. 1, 2, 3. Buddy. So 1n is going to come out, and 1n is going to stay inside. We got to figure out 27 to figure out if there's any number that goes there. So 27. 3, 9. 9 is special. 9 is a perfect square. 3 times 3 gives you 9. So 3 comes out, but this 3 stays in. Final part. U squared, U and U. Buddy comes out. V doesn't have anyone, so V has to stay inside. So U, V. And now we got to find 180. We can start with 2. 2 and 90. You can go try 5. That's 1 and 8, 18. I'm correct. 90 divided by 5. Yeah, 18. You can do 2 again. And there's 9. 9 is a perfect square. I can stop here. Because that's 3 times 3, so I know 3 is going to be out here. And then we also have a buddy here. So I know there's going to be a 2 out here. And 5 stays inside. I also had a negative 2 right there. So that's 2 times 3 times negative 2, which is negative 12 u 5 square roots of v. So notice for the variables, we are just pairing them up. So over here, when you get to a bigger number like p to the 15th power, how many pairs can you make out of 15? Well, you can make 7 pairs out of 15. So p to the 7th comes out, and a single p stays in. Because if I do 7 pairs of p, that gives me a total of 14 p's, which has 1 left over. Same for q to the 9th. How many pairs can you do out of q to the 9th? Well, you can do 4 pairs of q to the 9th with 1 staying in. Because 4 times 2 is 8, and 1 left over. And last, r doesn't have anybody, so r stays in. Final level. Putting it all together with stuff we've already done. Ish. So 12, square root of 12. I know 3 and 4. And I went straight there because 4 is a perfect square. That's 2 times 2. So we have 2 square roots of 3. So if I rewrite that, 2 minus 2 square roots of 3 over 4, that can actually be simplified. Forget about that, 2 over 4 is 1/2. Forget about that, 2 over 4 is 1/2. So it's really 1 minus 1 square root of 3 over 2. Similar idea here, 8, 2, 4. 4 is a perfect square. 2 times 2. So that's 2 square roots of 2. Plug that back in. Four over 2 is 2. 2 over 2 is 1. So that's negative 2 minus 1 square root of 2. And that's it.